sort of. They're trying to determine the shape of the beach. And what you're looking for maybe over time is change.
Okay.
And if there was a big storm that came in, it might just totally change the shape of this beach. So if you did this again and compared the two curves, you could see that. You have what's called, let's see, it's like an uphill hole and then the downhill. And the downhill is one of the numbers on it. Uphill is the one that has a hole in it that you use to look at the stake or the downhill pole and where the horizon of the water is, where the water meets the land on the other side.
Okay.
Okay, and that's your reference. So where that appears to cross that downhill stake, that's the elevation change. So you do that to each site, and then in Excel or some other program, you start adding up all those changes, and you plot that, and you can see the shape of the beach. We'll be doing trying to estimate the substrate composition, and that's just the mineral part of the beach, the rocks, sand, cobbles, boulders, and so on.
These are our different categories. So for our habitat, we're looking for sand. Then there's all the other rocky stuff on the beach, so your gravel, cobble, and then your shell mix. Then your large stuff like rocks, like boulders or like your bedrock. Look for drift logs, and then a number of seaweeds that you're looking for.
After that, then we do the habitat. And in this case, the habitat is probably the same. But when we get farther down the beach, you see some of the stuff has seaweed growing on it, and there's a classification for that in the habitat. But when we're doing the substrate, if there is seaweed, you try to ignore that and just figure out what the mineral composition of the beach is, or the rock composition. And that changes too. Like if you had a storm, it could just wash all the sand out and leave you with nothing but gravel, or it could pile the sand up all the way.